out. But before we do, I want to look at one other kind of drunk, a different subclass, calling this an E-drunk for Euclidean drunk. You may recall that in our first implementation, the usual drunk, we simplified things by saying the drunk moved either east, west, north, or south. I now want to remove that simplification and allow the drunk to, say, move on a diagonal. To do that, we're going to use a function we haven't looked at before called random.random. That's probably the most important function in the random class. It's a function upon which all the others are built, in fact. And what that does is it returns a random number in the range 0.0 to 1.0. So we'll first get delta x in that region. Now notice that this will always be a positive number, and we surely don't want our drunk to always be wandering eastward. So we'll take another use of random.random, and we'll say if it's less than 0.5, then we'll make delta x equal to minus delta x. Now you might think, oh, this is introducing a little bias because I've said less than, and suppose it hits 0.5. Well, the truth is it will almost never be 0.5 because the number of floats in this range is so large, it's highly improbable you'd hit any particular one of them. Then we'll do the same thing over here for y. And so now we've got new values, and then we'll return the tuple delta x, delta y. Almost ready to run a simulation, but not quite.